Hello guys, welcome back, and in today's video we're going to be talking about density and pressure. Okay, so first of all, what is density? Okay, so density is actually a measure of how compact, okay, or how concentrated something is. So the definition for density is the mass per unit volume of an object. So the formula for density is given as rho is equals to mass divided by volume. Okay, so the density here, right, rho refers to your density, and m refers to your mass, and v refers to your volume. So the density's unit can be different, okay, according to the unit of mass and volume. Okay, for example, if your mass is kilograms and volume is meter cubes, okay, if your mass is kilograms and your volume is meter cubes, then your density would be kilograms per meter cube. But if your mass is grams and your volume is centimeter cube, then of course your density would be grams per centimeter cube. So in exams, they might ask you to change back and forth between these two units. Make sure what the exam is asking of you. Okay, so if you look at this here, right, a gas has very low density because for the same amount of volume, right, there's like less particles inside here, meaning that the mass is very low here in a gas, and that's why the density will be low as well. But for solid, there's like so many particles concentrated inside, so the mass is high in solids, which means that the density is also very high in solids as well. So let's try to do one example on density, okay? So the mass of 50 centimeter cube of a liquid and measuring cylinder, okay, is 146 grams. So the mass of the empty measuring cylinder is 100. So we can know the mass of the liquid from here, okay? So the mass of the liquid is going to be 146 minus 100. Remember, this is the empty cylinder, this is the cylinder with the liquid, and so then that's why the mass of your liquid would be 46 grams. And you also know the volume, which is 50 centimeter cube, and it's asking you to find the density of the liquid in kilograms per meter cube. Okay, alright, so your 46 grams, if we convert it into kilograms, it will be 0.046 kilograms. Why? Because your 1 kilogram is equals to 1000 grams. Okay, and 50 centimeter cube. Now this one is slightly more harder to remember, okay, but here's the thing. 1 centimeter cube is equals to 10 to the power minus 6 meter cubes, or you can remember it in another way, which is 1 meter cube is equals to 10 to the power 6 cm cube. Okay, it will be helpful for you to really remember this information. So this will be 50 into 10 to the power minus 6 meters cube. So the density, right, rho is equals to m over v. Your mass is 0.046 divided by your volume, which is 50 into 10 to the power minus 6. Put that into calculator and you should get 920 kilograms per meter cube. Okay, alright, so there are some practical activities they might ask you to measure about density, but your approach should always be that density is equals to mass by volume, right? And you need to measure density, and there is no device for us to measure density. We can only measure the mass and volume and use this formula to calculate it. For example, if you're given a solid, right, what you will do is use a ruler to measure the length, width, and height. Okay, because why? When we find the length, width, and height, then we can calculate the volume already. And afterwards, use a weighing scale as this one to measure this mass of the solid. So we will have mass of the solid here, and you can simply use the formula density is equal to mass over volume, okay? But how about a liquid where you cannot measure length, width and height anymore, okay? So what you will do is, if you have a measuring cylinder, right? Let's say you have a measuring cylinder here. So what you will do is, first, measure this measuring cylinder first on a weighing scale, and that will be your mass 1. And afterwards, you want to put the liquid in, okay, which you want to measure. For example, let's say we're filling in about 10 centimeter cube of liquid here, okay? So we fill this in with liquid, and we try to weight it one more time again, okay? Weight the measuring cylinder with the liquid. So the mass of the liquid now would be mass 2 minus mass 1, okay? I'm sorry for this. Okay, so from here, right, you already know your mass already. What you need to know is your volume here. So volume can be read from the reading of the measuring cylinder, okay? But then your eye level must be perpendicular, okay, to the measuring cylinder to avoid parallax. And this is an important information that you must mention in your exams, okay? That you must avoid. If you look at this from above, you will see this as a different reading. That's why. And you will see that 10 cm, and you will see that if this shows you, let's say 10 milliliters, right? So you will know that 1 milliliter is equals to 1 centimeter cube. So from this, you already know your volume as well. So finally, use density is equals to mass by volume formula to find the density of the liquid here. Okay, sorry about this. All right. Now, as for pressure, right? So for pressure, we are simply measuring how much force, okay, we are applying over one unit area, okay? And that's why the definition of pressure is the amount of force exerted on a surface unit area, okay? That is your pressure. So let's try to write down the equation for it. So it's P, pressure, is equals to force over area, okay? It's how much force you're applying over one unit area. That is your pressure, okay? So the unit for it, if we use it from the equation, right? So force is newtons and area is meter squared. So pressure, the unit of pressure you need to remember is pascals. So 1 pascal is equals to 1 newton per meter squared. So how much force are you applying on a unit area? That is your pressure, okay? For example, let's take a look at this. A woman wearing heels and an athlete wearing a sports shoe. Why do you feel less pressure, okay? Why do you feel less pressure on a sports shoe? Because if you notice here, right, the amount of contact area here is so big here, okay? This is all the area. Okay, so meaning that the area is very big, so the pressure would be very small. So he's not feeling pressure at all. But as for a woman wearing heels, right? Oh, sorry. So as for a woman wearing heels, for her it would be the surface area is very small, only here and this tiny piece, meaning that the area is very small. And since they are inversely proportional to each other, she will be suffering from a lot of pressure. Alright? So let's do an example. A girl wearing 60 kg wearing high heel shoes stabilizes herself on a single heel. The heel is round with a diameter of 1.5 cm. Calculate the pressure applied by the heel on the horizontal floor. So notice here that the mass is 60 kilograms and your diameter is 1.5 centimeter. So the equation is P is equals to F by A, right? So you need to find your area. So A is equals to pi r squared. But rather than converting at the end, let's try to convert it here. 1.5 centimeter is equals to 0.015 meters. Alright, so that's why it will be pi 0.015 square, which should give you in calculator a value of 0.0007 meter square. Okay, and since P is equals to F by A in force, what we are going to add? So the force is, right, the force is the weight of herself applying on the shoes, right? It's the weight of her entire body, which is what? 60 kilograms, right? So that is why your force will be mass times acceleration due to gravity, which will be 60 into 10. And this will give us 600 newtons. And since P is equals to F over A, your pressure here would be 600 divided by 0.0007, which will give us around 84886 pascals. In other words, we can say that 848 kilopascals. Alright, and this is because this is a single heel. Sometimes the exam would tell you she's wearing heels, so in those times your area has to be twice, because why? A shoe has two sides. Okay, now pressure in liquids and gases. So the pressure in liquids and gases, they will always act equally in all directions. How you can test this is if you have a plastic bag, right, and you put water inside there and you try to poke many holes here, so you will notice that they will all jump out, okay, with the same force, with the same pressure. Okay, that's what you will notice, and it is true for both liquids and gases. But there's one thing that we need to learn, which is pressure with depth. So the pressure in liquids or gases, they will increase with depth, because the force at the bottom of the water column, right, is actually equal to all the weight of the water above. So let's see what I'm trying to say here. Okay, for example, right, this is low pressure. Why? Because let's say this is 10 meters depth. For medium pressure, let's say this is 20 meters, and for high pressure, let's say 30 meter. Okay, so the pressure at 30 meter, right, it's actually all of the weight from above. Okay, but for the medium pressure, right, it's actually just this amount of force of water. Okay, and for the low pressure, it actually has very little amount of water. Okay, the weight of the water above is very low. So let's try to derive a formula for it. Okay, so what's the formula for pressure with depth? So first of all, we know that density is equals to mass into volume. Okay, alright, so rho is equals to m over v. Alright, so meaning that rho is equals to m over volume for any shape's volume, right? Whatever the area, whatever the volume formula is, the general formula is always the area, which is the base here, multiplying with the height. Okay, so rho is equals to m over ah, meaning that mass is actually rho ah, and we know that P, which is pressure, is equals to F by A. So F, right, the force, for example, the force of the water above, okay, it's actually the weight as well. and that's why F is equals to mg divided by A. So let's try to substitute mass from here, okay, into this part. So this will be rho A H G divided by area. If you cross out areas, you will be left with the formula pressure is equals to rho G H. And this is a formula that you should definitely remember. You should know where it comes from too, okay, in case you forgot an exam and you need to derive it by yourselves again. So let's say we want to find out the pressure here, right? Why it will be greatest? Because the height will be 30. And why will the pressure be very low at the top? Okay, why will the pressure be very low at the top? Because the height is only 10 there. So mathematically, it will also be very less. So another concept that we should be familiar is called the atmospheric pressure. So on Earth, right, we have the atmosphere that is surrounding the globe. And that atmosphere is always exerting pressure on everybody on Earth, every living thing, every non-living thing, okay? It's exerting pressure. All right. So, but then we are able to withstand it because when we breathe in, when humans breathe in air, right? When we have our lungs inside here, the pressure is almost the same as the atmospheric pressure that is acting down on us. And that's why we're not feeling anything particularly, okay? So it will be useful to remember this tiny information as well. Why humans can feel the atmospheric pressure is because the pressure inside of our bodies is almost equal to all of the atmospheric pressure. Again, you should know that if you have a dog, a car, a submarine, a tall building, everything is affected by atmospheric pressure. And we'll actually learn that right now. So, the atmospheric pressure is usually measured by using a mercury barometer. Okay, so barometer is a device used for measuring pressure actually. So what we notice is that when we have high altitudes such as top of mountains or top of buildings, right, we have lower atmospheric pressure. How it can be actually checked is that if you put a mercury barometer here, right, if we have a mercury barometer on both sides, so you will be putting mercury inside there, and your measuring cylinder or your test tube would contain mercury as well. But since it has a low atmospheric pressure, right, imagine that this is the atmosphere around us, okay? So that is going to exert pressure, meaning that the liquid will go up here. But since it is a low pressure, it will only have a very short height. But if it is at sea level, which is low altitude, the pressure is so much higher when it's near to the sea level. And that's why when there is more pressure exerted by atmosphere, our pressure, our height of the mercury column is going to be much higher, okay? So there is a reason. So this value, okay, is 760 millimeters. If we use the formula P is equals to rho GH, by putting in mercury's density, the height which is 760 millimeters, and acceleration due to gravity which is 10, we will always get that the pressure, okay, the atmospheric pressure at sea level is 1.013 into 10 to the power 5 pascals. And this is always true, okay? So if you and I are standing in a classroom, on ground, wherever, right, our pressure will always be the same as the sea level. But why is the pressure, okay, it's actually higher near the ground? It's because of gravity. Since we're closer to gravity here, right, the Earth's gravity will pull the air, okay, as close to the surface as possible. Alright, and in terms of density, right, so when we are very high, okay, at the top of the mountain or landscape, as the altitude increases, the amount of air particles or the amount of gas molecules in the air decreases, okay? So that's why the air becomes less dense in the air, okay, than the one at the sea level. So you will notice that the air is very dense, okay, nearer to the ground level or the sea level, and that is why. So there will always be lower pressure at top of the mountain, and there will be higher pressure for us on the ground or near the sea level all the time. Alright, so let's try to calculate the actual atmospheric pressure, okay? So P is equals to rho GH. So the atmospheric pressure states that the density of the mercury is actually 13.6 into 10 to the power 3. Our acceleration due to gravity is 10, and the mercury column reading that we will have, right, at a normal surface area will always be 760 millimeters. Okay, which means it's 760 into 10 to the power minus 3, because we're converting it into meters for our calculation. You will always get 1.01 into 10 to the power 5 pascals. So try to put that in the calculator and see if you can actually get the same answer or not. Alright, so that is how you calculate our atmospheric pressure, okay? So pressure with depth. How much is the hydrostatic pressure experienced by a diver at 25 meters below the surface of the ocean? Okay, so that is a very commonly asked question in IGCSE. If we have an ocean here and a diver is swimming, okay, a diver is 25 meters below the sea level, okay? So first, calculate the total pressure, calculate the hydrostatic pressure. So hydrostatic pressure means the pressure exerted by the water. So hydro is your keyword, okay? This shouldn't be very difficult for you to figure it out. So P is equals to rho GH. So the density of the sea water, okay, the water that he is in is 1030. G is 10. H is, he's 25 meters, so 25. Put that into calculator and you will get 257500 pascals, okay? So to make this easier, this will be 2.5 kilopascals, okay? 1, 2, 3, 4, 5. But they're asking you again the total pressure. So you must know that in your mind that the atmosphere is always going to be acting on everything, right? So it's going to be acting on this water and sea as well. So your total pressure, P total, would be pressure of the atmosphere, which is P ATM, plus your hydrostatic pressure, which is 2.5 kilopascal. So this will be 1.01, sorry, this is 2.5 into 10 to the power 5, my mistake. (1.01 into 10 to the power 5 plus 2.5 into 10 to the power 5, so you should end up with 3.51 into 10 to the power 5 pascals. Alright, so let's do one last problem, okay, before I let you go. So if you have read the question, you will notice that there is atmosphere trying to push down this liquid. So when the pressure is pushing it down, the liquid will try to rise above as much as it can. So the difference in height is actually 3.8 centimeters. The density of the liquid is about this much. So calculate the difference in pressure. Okay, so it simply means trying to find your pressure here. So P is equals to rho GH. Your density is 1.3 into 10 to the power 4. Your G is 10 and your H is 3.8 centimeters. which will be 3.8 into 10 to the power minus 2. So never forget your unit conversions, okay? Alright, so you will get 4,940 pascals, okay? So this is how much the difference between the atmospheric pressure and the pressure of the gas here, okay? Because since it doesn't want to go up, it's going to push down as well. So that is the difference in pressure. So that is all for today, and I'll see you in the next video. Bye.